So based off of the poll, it looks like there's only 3 people, so we don't have a lot of votes, but 1 vote for radicals and 2 votes for rational expressions. So I am going to share my screen instead of the whiteboard. Now there are several things that rational expressions cover. So I'm going to make another poll so you can choose what topic for rational expressions. Rolanda figured out the chat box. Awesome. So your choices are domain of rational expressions, simplified rational expressions. We can cover adding or subtracting, or multiplication and division. So I'm going to set up a new poll. Here's the new poll. So out of rational expressions, choose the number 1 thing that you need help on. So you can only choose 1. It doesn't allow me to choose, you can't choose more than 1. So just choose the number 1, the one that you're having the hardest time with. Okay, so we've got 2 votes. Not everybody has voted. It says that we've got no response from. Okay, there we go. 3 of you. So we've got multiplication, division is the top one. So we'll do that first. And then we can go on to adding, subtracting. And then from there, then we can move on to radical. So I'll try to hit everything that you guys need help on, as much as whatever I can fit into an hour. Okay, so, and I will do this in a different color so that it's clear. Okay, so we are going to be looking at rational expressions, multiplying and dividing. Help if I spelled dividing right. Oh, I did. Brain fart there. Okay, so I have the textbook open in another screen, so I am going to pick some of the even problems from the textbook, from the section that this stuff covers. So the first even one that they have is a division problem. So we have r over r minus 1 divided by r squared over r squared minus 1. So that's our division problem. So when we are dividing fractions, they're basically dividing is the same thing as multiplying by the reciprocal. And so the reciprocal of a fraction is you're just flipping what is top and what is bottom. So we always flip what's after the division sign. So we're going to be flipping this r squared over the r squared minus 1. So that is our first step. And when we do that, we turn into a multiplication. And we have to use the dot for multiplication because if we use the x, it's a variable. So we're going to use a dot. And then that's going to be r squared minus 1 over r squared. So that's your first step, is to turn the division into multiplication. Your next step is to factor. So if we have anything that's a quadratic, or if we have something that we can take a greatest common factor out of, that's what you need to do. So our first fraction, the r and the r minus 1, there's nothing we can factor out of there. Second fraction, we have an r squared minus 1. That is a difference of 2 squares. That is something that we can factor. So we are going to be factoring the r squared minus 1. So the difference of 2 squares, that would be an r times an r. That's how you get r squared. And the difference of two squareds means you're going to have a plus and a minus. And then the two numbers that multiply to 1, well, that's just 1 and 1. And to get that negative 1 is a positive 1, negative 1. So we're going to factor that. Then on the denominator, the r squared, we can't factor. So we're going to rewrite this. So we have r over r minus 1 times, and then we're replacing the r squared minus 1 with the factored form. R plus 1 times r minus 1, and then in the denominator we have r squared. Are there any questions so far? Okay. So the next step is to cancel out common factors. So those are going to be the things that are the same on the top and the bottom. And I'm going to just highlight so you can see what is the same. So we have an r minus 1 in the bottom and an r minus 1 on the top. So we can cancel those out. The other thing we can do is we have an r on top and an r squared on the bottom. So r squared is equal to r times r. So if you want, you could write that r squared is r times r. And then you can see that then we can cancel out an r because we have one on the top and the bottom. So those things that cancel out, if you don't have anything left, you just write it as a 1. So that would be 1 over 1 because both of those things were canceled out. And then we have a r plus 1 over r. And then from there you just multiply. And when we multiply fractions, we multiply straight across. And we're just multiplying by 1. So our answer is r plus 1 over r. So we multiply across in order to simplify. Are there any questions? Okay, so that is multiplying and dividing with rational expressions. It doesn't matter what the rational expression is, the steps are the same. If you're dividing, you have to turn it into multiplication. And then once you're at the multiplication step, you factor everything that you can, cancel things out that match, multiply everything that's left over, and then that's your final answer. There is one thing that our book specifies is that when you cancel anything that cancels out, you want to restrict that from the domain. So we canceled out an r and an r minus 1. And when you cancel things out, you're dividing them out. And we can't divide by 0. So that means that r cannot be 0 and r minus 1 cannot be 0. Now the r minus 1 not equal to 0, I can solve that by adding 1 to both sides, and that tells me that r cannot equal 1. So, oops, I must have accidentally pushed a button there. Let me move this out of the way. So that is telling me that if it also wants to know what values are restricted from the domain, r can't be 0, and r cannot be 1. Because if r is 0 or 1, then we wouldn't be able to simplify. We wouldn't be able to cancel those things out because you'd be dividing by 0. Are there any questions? Yes, Rebecca.
I don't know if you can. Oh, yeah. Okay, Lena.
There. Okay, that's better.
Yeah, there we go.
Sorry about that. I have to use my phone to hear you, but I have to be on my laptop to see you. So it's kind of weird.
Are you using a? Are you on Safari or an Apple device?
I am. My phone is Apple, but my laptop is HP.
Okay.
Windows.
What browser are you using?
Windows. No. What is this one? The E. Which one is the E?
Edge or Internet Explorer.
Internet Explorer. Yeah.
Okay. Usually works. Yeah, it usually works better with Chrome. Okay. So if you're having trouble, I mean, you don't have to switch now, but maybe next time try it in Chrome and see if that works. Because I know that sometimes they do updates and then the sound doesn't quite work in one browser, but it works in another one. And I know Apple usually has issues. So
Apple's using the So the question is that when we're solving for this, so this was our equation, and I was going to solve, and I didn't add the R. If not, it can't equal 0 or R can't equal 1. Would I miss a point there? Because,
not on the assignments.
But on
so on the quiz, they specify quizzes, they have multiple choice. And so your week 2 quiz is going to actually be on the material from week 1. So this is a great question for the week 2. On the quiz, it's all multiple choice. So they will list these on the options. And so when you're picking it, you have to make sure you pick the one with the correct part of the domain. But most of the time, we don't bother writing these because it's just assumed that those values can't be 0.
I tried doing the post-test. I'm sorry, the post-test, and I didn't. I had to redo it because I didn't do good on the first one, but I didn't see that on some of them, so that's the reason why I was asking.
Yes, yeah. Okay. So you'll know because the quiz will list them or not. But on the assignment, we're not looking for those. We're just making sure that you can do the simplification, you can do the multiplication, that sort of thing.
Thank you very much.
You're welcome. All right. Are there any other questions on this type of problem before I move on to the addition and subtraction? Okay. So I'm going to try to find a little more complicated one in the textbook for the. Well, the textbook doesn't give you any good ones. I'm looking at what they have, and I'm like, I don't like the ones that they're giving. All right, well, we'll just pick one of these. All right, so let's just change colors here. So we're going to be looking at rational expressions. And we'll look at adding or subtracting. So let's see. I'm going to pick one with the 3 because that should have enough to make it, hit all the major things, and I can make it both addition and subtraction in here. Okay. So this is actually an odd-numbered problem that I modified slightly. So we have a negative 1 over x plus, actually, you know what? I'm going to make this just to really, I'm I'm going to just modify it slightly just to kind of hit all the major points that we might have to. Okay, this is probably going to come out nasty because I'm just changing up. And then let's just make a number here so that these are not all just ones. Okay. So negative 1 over 2x plus x plus 3 over x squared plus 1 minus 3 over x cubed plus x. So we've got multiple rational expressions here that we are adding and subtracting together. And whenever you have fractions and you're adding subtracting fractions, you have to get a common denominator. And so the first step before you get a common denominator is you have to factor the denominators, if possible, so that way you can see what you need to multiply by. So we're going to start by factor the denominators. So our first fraction, 2x, there's nothing to factor there. The second denominator is x squared plus 1. So if it's x squared plus 1, you can't factor that because there's no sum of squares. If it was x squared minus 1, you could, but that one we cannot factor. And then we have x cubed plus x. That we can factor greatest common factor out because there's an x in both terms. So if I factor out an x, I get x squared plus 1 in parentheses. So I'm going to rewrite this. I have a negative 1 over 2x plus x plus 3 over x squared plus 1 minus 3 over x times x squared plus 1. So I factored that last denominator. Now we need to get them to have a common denominator, and we do this by multiplying by whatever is missing. You know, if it's present in one denominator, we have to add it in the other denominators. So let's do this in orange. So our first fraction has a 2 and an x. So it has the number 2, and 2 isn't present in either two denominators. That would be like 2 times x. So I need to multiply. I need to add 2 to the other denominators. But if I add it to the denominator, I have to also put it on the numerator so that you're not changing the fraction. So I'm multiplying it by 1 because it's 2 over 2. So whatever I do on the bottom, I have to also do on the top. So I had to multiply it by a 2 because there's a 2 in that first fraction. Now, this first fraction also has an x by itself. So my middle fraction doesn't have an x by itself. It has a 2, and then it has an x squared plus 1, which we consider together. So I need to also multiply that fraction by an x. I'm going to just put it in the back here, so I'm kind of running out of room there. And the third fraction has an x by itself. It's already written there, so we don't have to multiply anything there. So now the other thing that we have to look at is, let's use that color. But 2 of our fractions have an x squared plus 1, but the first one does not. So we have to add or multiply basically the denominator of the first fraction by x squared plus 1 so that it matches with the other denominators. So we need to multiply by x squared plus 1. I'm trying to squeeze it in here, but it's kind of messy. So what I'm going to do is rewrite this so it looks clear with what we have. And don't cancel anything out because that defeats the purpose here. I'm going to put my 2x, the 2 times x, I'm going to put those in the front. And then my third fraction, I could multiply the 2 times 3, but I'm just going to write it so that you can see what it looks like. So I've just rewritten what I did so that it's not all smushed together. And so now all of my denominators are the same. They all have a 2, they all have an x, and then they all have an x squared plus 1. So we just built ourselves a common denominator by just looking at the denominators we had, seeing what's present, what is not present in a fraction, and then multiplying in order to get it there. This is usually where people get confused. So are there any questions before I move to the next step? Okay. So now that we've got this, wherever I see subtraction, you can turn that to adding a negative. And I put the negative with the top of the fraction, basically, with whatever the coefficient is in front. So that subtraction, that last one there, I just put it so that it's a -2, because that's going to make it a lot easier when we're combining these, because subtracting is the same as adding a negative. So now what I'm going to do is multiply all the tops of the fractions. And this minus, oops, I didn't mean to get rid of the whole fraction. That minus there I can also put with the top of the fraction. So I'm going to just do my distributing on the top and leave the denominators the same. So first fraction, I have a -1 times x squared, so that's -x squared. And then a -1 times a 1, which gives me -1. Okay, second fraction, I have 2x times x, so that's 2x squared. And then 2x times 3, so 2 times 3 is 6, so that's a 6x. And then our denominator is the same. And then the third fraction, we have -2 times 3, so that's -6. So I'm going to have a -6 on top. And then my denominator is the same. Once you do that, now you are going to add and subtract these fractions. In this case, they're all adding them. And what I do is I write them all as a single fraction before I start simplifying, because it's just, you're less likely to make mistakes that way. So I'm going to just write these as one fraction. So we have a -x squared minus 1 plus 2x squared plus 6x and minus 6. So I'm just taking all of the numerators, sticking them together, and then because the denominators all match, we can make this a single fraction. And now I'm going to add like terms on the top of my fraction. So I have a -x squared plus 2x squared, so that actually comes out to an x squared. And then I have a plus 6x, and then I have a -1 minus 6, so that's minus 7. And then we have 2x times x squared plus 1. Once you get to this point, you want to see if it's possible to factor to see if you can actually cancel anything out. Most of the time things don't cancel out, but it's always worth checking. So the top of our fraction here, so I kind of made up these numbers and I got lucky. This is actually something that factors, because the top of the fraction, when we factor that, we have an x squared plus 6x minus 7. We want to multiply to -7 and add to a positive 6. So if I have a positive 7 and a -1, that gets me a positive 6x in the middle, and it multiplies to a -7. So I factor and then I look to see if there's anything that I can cancel out. In this case, there is not. I can't cancel out any x's because they're all grouped together with numbers. It's like an x plus 7. I can't just cancel an x out because it's grouped with the x plus 7. Just like the other one is the x minus 1. Those are grouped together. So there's actually nothing that I can cancel out here. So in that case, you can just use your previous step as your final answer. If you want, you can give the factored form as your answer. There's nothing wrong there. And if you wanted, you could distribute in the denominator, but you don't have to. That's just extra work. That's not necessary. What's the important thing is showing that you've correctly added these together and then checked to see if anything can cancel out. And most of the time it does not. That's very rare when it does. So are there any questions on any of the steps here? Usually these are longer step problems to add and subtract. They take a while. They definitely take several steps. Yes, Rebecca.
The question that I have is in the very beginning, right under where you're saying factor the denominators, and you're adding 2 to the very last equation. So the 2 is only factored into the 2x. You're not factoring into the 2x plus 1. I think that's where I kind of get confused at, because I'm thinking I'm trying to add that 2 to the whole equation.
Right, yeah. So basically this is 2 times an x times an x squared plus 1. So we're not actually, it's not like you're distributing multiplying by the x and the x squared plus 1, because it's not a plus or minus in between those two. It's a multiplication in between those two. So it just kind of gets stuck together.
Okay.
If it was like an x plus, if there was a plus or minus between the x and the x squared plus 1, then you would have to multiply it by both. But if it's not there, then it's just kind of attached. They're all just multiplied together.
Thank you. I was just double checking. I think that's where I get kind of a little confused at.
A lot of people get confused with that. I see that a lot of people multiply too much with things like that. They will multiply the 2 too many times. And so that's a good thing to get a clarification on, so that you are aware. And no, okay, no, I don't do that, because it's not a plus or minus in there, so it's not distributing, it's just getting attached. Are there other questions? Okay, so let's zoom out a little bit here. So the other thing was radicals. So I'm going to put up another poll so we can cover the kinds of things that you want to see. So I'm going to do radicals with variables. That's the default here. But whether you want to see something with a square root, something with a cube root, or something higher, like as a 4th or a 5th root. So I'm going to just start this poll. And so you can choose the number 1 thing you want to see. And while you guys are doing that, I am going to get to that area of the textbook. Okay, you guys all match. You all want to see a higher root. Okay. radicals a higher root. Okay, so let's see what we've got in the textbook that I can pull from. Okay. So we're going to do a fifth root. And it's 160 x to the 8th z to the 4th. So the type of root, it tells you how you want to group things out when you try to simplify. So we want to try to make things in groups of 5 or with an exponent that is 5 or multiple of 5, because that will allow us to simplify. The first thing I start with is the number. So the book just kind of splits these numbers up. It doesn't really explain how it splits the numbers up. I do prime factorization. So I start by making a factor tree. So I'm going to take my 160, and then I just split it up as two numbers that multiply to 160. And you can split it up any way you want. As long as you just keep splitting, you'll get the same answer. So when I look at 160, the first thing I think is oops, I don't know where that horizontal line came from, but 16 times 10. I know for sure that will give me 160. So I just try to choose the easiest thing. And then you keep splitting up if you can multiply those. Like 16 is 4 times 4. So I'm going to split 16 up. And then 4 is 2 times 2. So I can split each of those up. But I can't split 2 up. It doesn't split up as two numbers that multiply to 2. So if I get to the bottom, I put little circles around that. So now I got to do the same thing with my 10. And that's 2 times 5. It's a little sideways there, but you get the idea. And that one, those can't go any further. So what I do is I do this factor tree, and I split the numbers up as far as I can go. And then I count how many of each number I have. And these are all going to go underneath the root. So I have 1, 2, 3, 4, 5 2s. So that's the same as 2 to the 5th power. And then I have a 5. So I don't have any other numbers that I've circled. So you go off of the bottom numbers, the numbers that you circle. So 160 is the same as 2 to the 5th power times 5. Now my goal is to group these things up in 5s. So 2 to the 5th, that's already grouped 5 together, so I don't have to do anything there. The 5 by itself doesn't have anything to group together, so I'm going to move on to my letters. So we've got x to the 8th. So x to the 8th is the same as just x times x times x times x. 8 x's together. 1, 2, 3, 4, 5, 6, 7, 8. We want to try to group these in groups of 5 because this is a 5th root. So let me circle. So we got 5 of these together. That's x to the 5th. And then the other 3 is x to the 3rd. So that x to the 8th, I'm going to split up. So that's x to the 5th times x to the 3rd. It's the same thing. I'm just trying to split it up so that I have groups of 5. Now the z to the 4th, there's 4 z's, so there's no way that I can make that in a group of 5, so I'm going to just leave it as z to the 4th. I drew my line too long. So what I've done is taken what I had written, and then I'm trying to split it up into smaller pieces and trying to group them by 5 if possible. Before I move on to the next step, are there any questions on what I've done so far? Okay. So now what I'm going to do is I'm going to take everything that has this exponent of 5, and I'm just going to rearrange them and put them in the front, and I'm going to put them in their own root, because with square roots, if everything is multiplied together, you can split them apart. So I'm going to split this up so that I have the 5th root of 2 to the 5th, and then I'm going to split it up so I have the 5th root of x to the 5th. So I've just split those up, and then everything else that didn't have an exponent of 5, I'm going to stick under the same root. And this is all just, it's implied multiplication. You don't have to put the dots, but you can do that. If they're all underneath the same root and it's all multiplied, you can kind of split them apart. Now, when you have a 5th root with an exponent of 5, these things cancel out. It's like a square root of something squared. It cancels out. And the same thing here. Those all cancel out. So you're left with just the base of the number, which is 2, and then an x, because the exponent got canceled out by the root. And then we have this 5th root of 5, x to the 3rd, z to the 4th. And once you've done that, if you can't multiply anything together in the front, like 2 times x doesn't really do anything, then that's your final answer. So our answer is 2x times, so that's the multiplication there, just so that the 5 doesn't go with the x to the x. It's not an exponent on the x. It's going with the radical symbol, the root. And then it's the 5th root of 5, x to the 3rd, z to the 4th. Are there any questions?
Another question, Jim?
Yes, Rebecca.
If I didn't add that little multiple dot there and I left that blank, so that's not applied, I would have to put that multiplication factor there.
Like this?
In the very beginning
Oops.
of the sorry, in the very beginning of the square root of 5, so the 2x. If I didn't put a multiplication like the little dot there before that, would that be wrong? Or is
No.
it applied?
It's implied.
Okay.
Yeah, it's implied because there's no plus or minus in between, so we assume it's multiplication. I just put it there because I didn't want it to get confused with that 5 and look like an exponent.
Okay, makes sense. Thank you.
Yeah, so the other thing is usually I try to be very careful, maybe leave a gap or try to put that 5 as close to the symbol as possible so it doesn't look like an exponent. Do you guys have other questions? Okay, are there other topics that you guys might want to see worked out or other examples? Do you have any questions that are not like problem related, but maybe about other things in the class?
Sorry.
No, it's fine.
Is there a way to work out this one problem? It was part of the post-test, and of course they change the answers change the questions whenever you try to redo it. But I was
Right.
having issues with the solving this one. And
Okay.
it was the 3 square root of m plus 4.
Okay. 3 square root of m plus 4.
Now multiplied by 2 square root of m minus 6.
Minus 6. Okay. So, when you have a problem like this, it's just like a simplifying expression kind of thing. You can treat these square roots of m sort of like variables. So, if those are confusing to you, what you could do is say, usually use the letter U if we're going to do any substitution. And so you can just temporarily replace that square root of m with a u, if those are kind of confusing you. And then that usually when people do that, they say, oh, okay, I know how to do this type of problem, because it looks like it looks simpler. So when we're simplifying here, the first thing you need to do is distribute. So we have to multiply that 4 through the parentheses. So we're going to have a 3u plus, and then you're going to do 4 times 2u. So 4 times 2 is 8. So that's 8u. And then 4 times negative 6 is negative 24. So now we can see that we have like terms. We have the 3u and the 8u, so I can combine those. 3 plus 8 is 11. So we get 11u minus 24. Then once you're done and you can't simplify that any further, you go back and you replace u back with that square root of m. So you get 11 times the square root of m minus 24. And so that is your answer. If you wanted to, you could work the problem with the square roots. It works the same way. You're still multiplying 4 times 2. You're still adding the 3 and the 8. It's just a different looking variable that's attached to it. It's instead of just a regular variable, we have a square root with it, but the steps are the same.
Thank you. That helped a lot, and actually it really did. Thank you.
Good. Yeah, this kind of trick is not taught too often, and I think it's because people often forget at the end to put the original thing back in there. But it's a really handy trick because then you can see that you're not doing anything different from what you've already done. It just looks different. Like on the assignment, there was a question, I don't remember what the exact numbers were, but I think it was something, I don't know if these are the exact numbers, but it was like this. You could have done the same thing and say, okay, instead of having the square root of 5, I'm going to do it with a variable u. So you could then do the same thing, and then you see, oh, it's just a FOIL problem. So then you just go and you FOIL everything out. So 3u times 3u, that's a 9u squared. 3u times negative 4, so that's negative 12u. 4 times 3, that's 12u. And then we get a negative 16. The u's in the middle, those cancel out. You get 9u squared minus 16. Then you go back and you say, okay, I'm going to replace my u with the square root of 5. So this is where it gets a little trickier. But when we square a square root, those cancel. So that square, oops, I did not mean to do that with the black. I thought I had the highlight. This 2 cancels out our square root symbol. So all we're left with is the 5. So you're left with 9 times 5 minus 16. So that's 45 minus 16, and then you just 45 minus 16, whatever that comes, 29. That is a messy looking 16. So you can even do that trick if you don't have variables underneath the square root. And it kind of helps you just see what type of problem it is. And you see, oh, that's a FOIL problem. Okay, I know that I'm going to do FOIL. So this is not the exact same question that was on the assignment, because I think on the assignment it might have also had imaginary numbers too. I don't exactly, well, it didn't have imaginary numbers. It had something where you ended up with something else. I don't remember, but very similar.
No, that was very helpful. Thank you.
Good. Anything else that you guys can think of? Yeah. Go ahead, Rolando.
Yes, something with the assignment, letter G,
Mm-hmm.
where they have the fraction.
Okay, I'm going to pull this up so I can see the exact problem. This one right here?
Yes, yes.
Mm-hmm. Yeah, what's your question about it?
So the common denominator, would that be x minus 4, and then you just multiply that by 4 minus x?
Yes, so you can do this one multiple ways. So that is one way to do it, because they're not the same thing. This particular problem has a little trick to it. So this denominator of 4 minus x, I can rewrite that as negative x plus 4. If I just flip-flopped the x's.
Okay.
If I have a negative in front of the x, or a negative in front, I can factor out a negative 1. And what that does is it switches the sign. So that would be a negative 1 times an x minus 4. So if you notice that little trick, then you see that they are almost the same. You would just have to multiply the first fraction by a negative 1, and then they are the same. But if you multiplied both of them, like if you had done 3x and multiplied it by the 4 minus x, and done the x minus 4 by the 4 minus x, and then done the 2 by the x minus 4, you would get the same answer. It might be a few extra steps because you'd have to simplify and something will cancel out after you get to that end, but you get the same answer.
Okay, all right. All right, thank you. Yeah,
You're welcome.
All you gotta just see is just the negative, factoring out the negative 1.
Yeah, it's a little trick. And then what's even trickier on this one, I like this one because it kind of, if you see the tricks, it's not as bad, but otherwise you can do it like normal. But because we have this negative here and then that negative 1, what happens is you end up, we have this 3x over x minus 4, and I'm going to write this. We have a negative 2. If I put that 2 with that negative 2 like I did with the other subtraction, and then I have my negative 1 and then the x minus 4, these two negative signs cancel out.
Okay.
So what makes it really cool is then you end up with 3x over x minus 4 plus 2 over x minus 4. And then it actually is just really not a lot of steps after that at all, because you're just literally adding 3x plus 2.
3x plus 2, okay. All right.
Yeah.
Okay, thank you.
You're welcome. Any other questions? Okay. Well, if you guys think of anything, of course, you're welcome to email me. If I'm not available, tutor.com is available 24/7, so they're really good for getting help. Just to forewarn you, week 3 is going to be a doozy of a week. So if you end up having some free time this week, you may want to start working ahead just to give yourself some extra time for week 3. So week 3 is kind of a doozy. This week's not too bad. So just to give you a little forewarning there. But of course, that's depending on your schedule and how that goes. But yeah, so thank you guys. I guess I can stop sharing my screen. So thank you. I'm really glad that you guys attended and had questions. That's totally awesome. Tomorrow morning, I'm going to upload this to YouTube, and I will put it in the classroom. So it'll be that very first video that you see when you log into the classroom. It's going to replace I think is the course intro video that's there right now. So it's going to replace that, and then I'll just change the title so you'll see when that new video is up. I will also put it in the video link on the left side of the classroom, and I'll put it under, because we covered week 1 material, I'm probably going to put it under the week 1 material so that it matches with that. If you have the Blackboard app on your phone, it will actually send you a notification when new things are added. So you'll be able to find it there, and I will also include the OneNote that I was working on, all the work. I'll have it save that as a PDF, and then I'll upload it with that, so you'll have access to that as well. And then I'll definitely be doing one during week 3. It might, I don't know if it's probably going to be more towards the end of the week, because I know week 3 is going to be a doozy, so I'm going to give you guys some time to work through the material before you have questions. But I'll have to see what everybody's schedule looks like, what the survey results say as far as when people are available, that sort of thing. But yeah, thank you guys. I'm really glad that you guys were able to attend. That's really awesome. And I hope that you guys are staying safe, doing well, nobody's getting sick. And I hope you guys have a great rest of your night. And be happy that tomorrow's Friday. Yay. So, all right. You guys could just close the window, and I will talk to you guys next time.
Have a good night. Thank you.
You too.